Let's face it, keeping tabs on IT systems these days, it feels like trying to hold back a tidal wave with, I don't know, a teacup.
Uh-huh.
The sheer volume of data, the complexity, it's constantly growing. And that puts, well, immense pressure on IT auditors, right? To ensure everything's secure, working as it should. You
Absolutely.
just have to wonder if there's a smarter way, maybe a more effective way to tackle this huge task.
Absolutely. And that's exactly where this idea of anomaly detection
Mm-mm.
really starts to spark some interest.
Right.
We've already seen how this kind of technology has, well, revolutionized other fields. Think about financial audits, how it flags suspicious transactions. So the core question really is, can we harness that same power, the intelligent pattern recognition, to make IT audits not just more efficient, but, ultimately more insightful?
Okay, let's unpack this then, because that's exactly what we're plunging into today.
Hmm.
We're doing a deep dive into the thesis Anomaly Detection in an Audit, the possibilities and potential in the domain of IT audit by Tom DeFries. And this isn't just a hunch, right?
No, not at all. It's based on a pretty thorough look at existing research and also some really insightful conversations with IT audit professionals at EY, actually.
So our mission today is to really get under the hood, explore how this anomaly detection could potentially reshape the whole IT audit landscape.
And the central question that, Tom DeVries's work really grapples with is this. How can anomaly detection be applied to the IT auditing process to make a significant contribution to the efficiency and/or quality?
Hmm.
It's a question that just gets more critical with every, well, jump in IT complexity.
Yeah, I can see that. So, okay, before we get too far ahead, let's just make sure we're all on the same page about what IT audit actually is.
Good idea.
Our source material, referencing Gantz, defines it as examining IT processes, the IT assets themselves, and the controls that are in place, all against like established standards and requirements.
Right. It's about checking against the benchmark.
So what are the main goals here? What are they trying to achieve?
Well, drawing on Romney's work, the objectives are pretty comprehensive. It's things like making sure the overall IT security is, robust,
Okay.
that changes to programs or introducing new systems, that those are properly authorized.
Right. Control over change.
Exactly. Making sure data processing is accurate, and critically, that the integrity and confidentiality of our digital information are maintained.
So basically, confirming IT is working reliably, effectively, doing what it's supposed to do.
That's the essence of it. Yeah.
And the crucial elements that ensure this. That's the controls we always hear about. I know there are different types.
Precisely. Controls are key. Gantz categorizes them by their nature. Are they designed to prevent problems, detect them after they happen, or correct issues that have been found?
Preventative, detective, corrective. Got it.
Yeah. And then Romney gives examples based on their function. You've got administrative controls, like policies and procedures.
Okay.
Technical controls, the firewalls, encryption,
Uh-huh.
and physical controls, like security guards, locked server rooms.
Mhm.
These are the things IT auditors are meticulously evaluating.
Okay, so we have a good handle on what IT audit's all about. Now, let's talk about how it's typically done and maybe where the cracks are starting to show.
Right.
Romney outlines the usual steps: planning, gathering evidence, evaluating that evidence, and then, communicating the findings. Where does this traditional approach maybe fall short today?
The thesis really shines a light on that evidence collection phase,
Mm.
specifically the long-standing reliance on random sampling.
Ah, sampling. Okay.
Yeah. Auditors often take a pretty limited sample to test IT general controls
Mm-hmm.
or ITGCs. Those are the broad controls affecting the whole IT environment there. Think password policies, data backups.
Right, the foundational stuff.
Exactly.
Yeah.
And they also sample IT application controls, ITC specific to software,
Mm.
and IT-dependent manual controls, ITDMs, where a person's involved.
And the sample sizes, they aren't huge, are they?
No, that's the point. At a firm like EY, for instance, the thesis notes they might be quite small, say 5 to 25 for those big ITGCs, and often just a single sample for ITACs and ITDMs.
Wow, okay. And the argument here is, with the sheer explosion of digital activity, just picking a handful like that, you might be missing the forest for the trees.
That's exactly it. The thesis posits that the traditional assumption that reviewing every single transaction or event just isn't feasible.
Well,
That might be outdated now.
with the tech we have available.
Precisely. We're essentially only looking at a tiny, tiny sliver of the whole picture with random sampling.
Which brings us neatly to the technology that could potentially change all this: anomaly detection. In its simplest form, what exactly is it?
In essence, as Chandola and colleagues defined it back in 2007. It's about spotting those data points or patterns that just don't fit the expected normal behavior.
Finding the odd one out.
Exactly. The digital equivalent of finding the odd one out in a lineup.
Now, we hear AI thrown around constantly. Where does anomaly detection fit in that whole vast landscape?
Yeah, good question. The thesis makes a helpful distinction. There's narrow AI, which is designed for a specific tasks like this. And then there's the more sort of futuristic concept of artificial general intelligence, AGI.
Right, the sci-fi stuff.
Kind of.
Yeah.
Our focus here is firmly in narrow AI, and even more specifically, within machine learning, or ML.
Okay.
ML algorithms are really the engine driving these anomaly detection capabilities.
And this isn't just some, like, pie-in-the-sky idea, is it? We've seen it work in practice.
Oh, absolutely. Chilapathy and Chola's 2019 research highlights successful uses across sectors like insurance, healthcare, and, crucially for us, financial fraud detection.
Right.
The thesis even points to a specific example, EY Japan's Helix Gilead system. It's designed specifically to flag unusual patterns in general ledger data that might point to fraud.
So a real-world example right there in the audit context.
Exactly. It really underscores the potential.
Okay, so fundamentally, how does this magic actually work? How does it find these anomalies?
Well, the basic principle is all about building a model of what normal data looks like. For a given process, what's the typical behavior?
Establishing a baseline?
Precisely. Once the algorithm has learned this baseline, it can then identify any data points or patterns that, deviate significantly from this established norm. Those are the anomalies, the outliers, that warrant a closer look.
And are there different ways these systems go about finding these unusual patterns, different techniques?
Yes, several. Mehrotra and others outlined a few approaches. Some look at how far a data point is from others, that's distance-based.
Okay.
Others look at how densely data points are clustered, density-based. And then there are model-based methods which build that model of normal data and see how well new data fits.
Interesting. And the data itself can be different types too, supervised, unsupervised.
Exactly. It depends on whether the data comes with pre-labeled examples of what an anomaly looks like. Supervised means it has labels, unsupervised means it doesn't, and semi-supervised is somewhere in between.
The thesis seems particularly keen on unsupervised deep learning using deep autoencoder neural networks. DENs. That sounds pretty advanced.
It is quite advanced, but the concept is actually fairly elegant.
Okay, break it down for us.
Sure. So the thesis, drawing on research by Schreier and others, suggests these unsupervised deep learning methods, especially DENs, hold a lot of promise. Think of an autoencoder, as Goodfellow and Corville describe it, like this. It's a type of neural network trying to do a simple task, copy its input to its output.
Okay.
To do that, it has two parts. An encoder, which compresses the input data into a smaller representation.
Like zipping a file.
Sort of, yeah.
Yeah.
And a decoder, which then tries to reconstruct the original input from that compressed version.
Okay, compressing and unzipping. Got it. So where's the anomaly detection part?
The crucial bit is that the autoencoder is trained only on what we consider normal data. It learns the most efficient way to compress and reconstruct that typical data. Now, when it encounters data that's unusual, anomalous, it won't be able to reconstruct it as accurately, because it hasn't really learned the patterns for that kind of data. So the difference between the original input and the reconstructed output, we call that the reconstruction loss that becomes our red flag.
A bigger difference means it's more likely an anomaly.
Exactly. A larger loss suggests it's unusual. And because it's unsupervised, it can learn what's normal without us needing to feed it labeled examples of anomalies first.
That is a really neat approach. But the thesis is careful to point out this tech isn't meant to just replace human auditors, right?
Absolutely not. That's a key point. The prevailing view, and certainly the view in the thesis, is that these tools would act as powerful assistants.
Like a partner.
Yes, highlighting potentially suspicious items so that human auditors can then apply their professional judgment, their expertise, to those specific cases. It focuses their attention.
Okay, that makes sense. Now, the thesis also went out and talked to people actually doing IT audit at EY. What did they see as the main advantages, the upside, of using anomaly detection?
Yeah, those interviews were really insightful. Several key benefits kept coming up.
Like what?
Well, one big one was the potential to ease the growing workload burden on IT auditors. And related to that, the increasing difficulty in recruiting and retaining talented people in this field. It's demanding work.
So automation could help with capacity issues.
Definitely. By automating that initial scan for anomalies, auditors could focus their skills on the more complex, nuanced issues that really need human insight.
That makes perfect sense. Let the machines do the initial sifting. What else?
Another major potential benefit was the possibility of significantly increasing the level of assurance.
How so?
By being able to analyze the entire population of data, every transaction, every log entry, potentially, rather than just a small sample.
Right. You get a much fuller picture.
A much deeper, more comprehensive understanding of what's actually happening. You could potentially uncover issues that traditional sampling might just completely miss.
And I guess the flip side of that is focusing attention.
Exactly. It allows auditors to really zero in on the things that genuinely look suspicious, rather than spending valuable time investigating randomly selected items that, more often than not, turn out to be perfectly fine.
Okay, those all sound like really compelling reasons to explore this. But of course, bringing in any new tech like this, it's bound to have challenges, hurdles. What did the interviewees anticipate?
Yes, several key challenges were definitely identified. A really fundamental one is just how deeply ingrained random sampling is in the current IT audit methodology.
It's the way things have always been done.
Pretty much.
Hmm.
So the idea of analyzing everything flagged by an anomaly detection system, that might feel like a really big shift from that established way of working.
A cultural shift, almost.
Could be. And there were also understandable concerns about a potential increase in workload, paradoxically.
How's that?
Well, for the auditors, who might need to investigate a larger number of flagged items, even if they are more targeted, and also for the clients.
Ah, right, because they'd need to provide more data.
More data, potentially, and more explanations for why something the system flagged as anomalous is actually okay.
Yeah, I can see how that could potentially strain client relationships if suddenly there seem to be way more findings or questions being raised.
Exactly. Perception matters. What other roadblocks came up?
Ensuring the reliability and trustworthiness of the algorithms themselves, what people often call algorithm assurance, that was a big one.
Makes sense. You need to trust the tool. Absolutely. And related to that, the critical need for transparency. Auditors need to understand how these systems arrive at their conclusions. They can't just be black boxes.
Right, you need to be able to explain it to the client, to
Yeah.
regulators.
Exactly. Which speaks to this whole growing field of explainable AI. And reproducibility was another key thing, making sure the results are consistent and reliable if you run the analysis again.
So it's not enough for the box to just spit out anomalies. You need to understand its gears and levers and be able to justify its output.
Okay. The thesis also looked into factors that might influence success here. What were some key variables?
Yeah, it categorized these factors pretty neatly into 3 areas. Person, the auditor's knowledge and skills.
Okay.
Task, the characteristics of the audit task itself.
Yeah.
And environment, the broader context.
What kind of task characteristics matter?
Things like the potential impact if a misstatement goes undetected, how standardized the process is that's being audited, its complexity, the sheer amount of data involved, how often the process runs, for how long. All these things influence feasibility.
And under the environment category, what factors are playing there?
Key things there included the existing audit methodology and, critically, how flexible it is to change. The size and complexity of the company being audited, any time pressures the audit team is under, the availability of those explainable AI tools we mentioned, and, crucially, the overall relationship and trust between the auditors and the client. Right, all those external factors, each one could either help or hinder adoption.
Exactly. It's a complex interplay.
So based on all this, considering the potential and the challenges, the thesis identified some specific areas, some use cases, where anomaly detection looks particularly promising for IT audit. Let's explore those. The first one focuses on managed change, or MC. What's the core idea?
Okay, so this use case, which the thesis calls MC anomaly-based sampling, targets IT risks around how organizations manage changes to their programs and IT configurations.
Like software updates, system settings?
Exactly. Specifically, it aligns with some common IT risk areas, like inadequate testing of changes, inappropriate changes being made, or unauthorized configuration tweaks.
Okay. And how would anomaly detection help?
The central idea is to use anomaly detection to analyze the complete record of changes, say, within standard systems like SAP or Microsoft Dynamics, looking for changes that deviate from the norm in ways that might signal a problem.
So instead of randomly picking, say, 25 changes to look at.
Right. The system flags the ones that look statistically unusual based on patterns it's learned, and the auditors then concentrate their efforts on those specific instances.
Exactly. The audit sample would then be drawn directly from these flagged anomalies, This should make the testing much more targeted, much more risk-focused.
And potentially uncover risks you'd likely miss just picking randomly.
That seems like a big potential win. The thesis even mentioned the possibility of training a general model.
Yeah, that was an interesting idea. Because systems like SAP are relatively standardized, you might be able to train a general anomaly detection model on data from multiple clients using similar setups.
Creating efficiencies across audits. Were there specific challenges noted for this managed change use case?
Yes, a couple. One practical issue is that different organizations might use various other systems, like email or ticketing platforms, to document parts of their change process. That can create inconsistencies in the data.
Right. Data quality is always key.
Always. And as we've discussed, that fundamental challenge remains. The current audit methodology's emphasis on random sampling would likely need to evolve to fully embrace this anomaly-based sampling approach.
Okay, let's move to the second promising use case. This one focused on manage access, or MA, looking at segregation of duties, SOD, and potential fraud. How does anomaly detection fit here?
So this one, titled MA, SOD Concerns and Fraud Detection, tackles the risk of individuals having conflicting access rights within IT systems.
Like someone being able to both create and approve payments, for example.
Exactly. Those kinds of combinations could create opportunities for errors or even deliberate fraud. The thesis points out that managing user access tends to be a bit more standardized across organizations.
Especially if they use dedicated tools.
Right, especially when they use tools like SAP GRC for access management. That standardization helps.
And the potential here is to spot those risky combinations that might slip through the cracks with normal testing.
Precisely. By analyzing the access privileges of all users, anomaly detection could flag unusual or high-risk combinations of permissions that warrant a closer look, things that might not be obvious otherwise.
And could this link up with other audit areas?
Yes, there's exciting potential there to link this access data with, say, financial audit data to get a more holistic view and potentially enhance fraud detection capabilities significantly.
That sounds powerful. Any specific challenges mentioned for this access management use case?
One challenge noted is that the definition of what constitutes a critical user profile, or a particularly risky combination of access rights, can sometimes vary quite a bit, depending on the specific client and their unique business processes and risks.
So some customization might still be needed.
Potentially, yes. You need to tune it to the client's context.
Okay, these two use cases, manage change and manage access, sound like really solid starting points. Based on all this research, what does the thesis suggest as the crucial next steps? How do we actually start putting these ideas into practice?
Well, the thesis recommends initially focusing data collection efforts on larger clients who are using similar common IT systems, like the SAPs or Dynamics we mentioned. That provides a good base.
Makes sense. Start where there's standardization.
And a really practical suggestion was to explore using historical data from past, already completed substantive testing engagements,
Why historical data?
to develop and test initial anomaly detection models without immediately impacting ongoing client audits. It's a lower risk way to start.
Ah, like a sandbox.
Exactly. And it allows for a valuable comparison. What did the anomaly detection system flag versus what did the traditional manual testing identify in that same historical data?
That's a smart way to pilot and validate. What about preparing the data itself? Any specific steps needed there?
Oh yeah, data prep is absolutely critical in any machine learning project.
Hmm.
This includes things like normalization, making sure different data types are on a comparable scale, and potentially dimensionality reduction, which is a way of simplifying the data, reducing the number of variables, without losing the key information needed for the analysis. Makes the models potentially more efficient and robust.
Got it. And when it comes to choosing the actual anomaly detection techniques, what did the thesis recommend as a good starting point? Which algorithms?
Given the nature of anomaly detection, where you often don't have clear, pre-labeled examples of anomalies, the thesis suggests starting with unsupervised deep learning methods.
Like those autoencoders we talked about.
Exactly, like autoencoders or perhaps recurrent neural networks, RNNs, which are good at handling sequential data. These types of algorithms can learn patterns from unlabeled data, making them really well suited for this kind of find the weird stuff task.
So we're back to the autoencoders again, and that point about needing to explain the results, that was highlighted as a key next step too, right?
Yes, absolutely paramount. The need for explainable AI or XAI cannot be overstated in audit. Auditors must be able to understand and justify the findings produced by these systems.
No black boxes allowed.
No black boxes. And the thesis also acknowledges that fundamental challenge posed by the current audit methodology. It stresses the need for more research into how the methodology itself might need to adapt to really integrate anomaly detection effectively.
So it's not just about plugging in new tech. The whole process might need rethinking.
To some extent, yes.
Yeah.
Though one potential initial approach mentioned was maybe using anomaly detection to help create a more targeted but still statistically valid sample for traditional audit procedures. Sort of a stepping stone.
A hybrid approach to start. Okay. So to wrap up our deep dive into this thesis, what's the main takeaway for you? What's the bottom line?
I think the core takeaway is that anomaly detection holds really significant potential to, well, maybe not revolutionize overnight, but certainly enhance IT audit, making it potentially both more efficient and more effective.
By moving towards analyzing the full picture.
Exactly. By enabling that shift towards analyzing the entire data landscape, it offers the promise of a more comprehensive, more insightful level of assurance. But, and it's an important but we go, realizing this potential needs careful thought about those methodological challenges and a strategic step-by-step approach to actually implementing it.
And the two use cases we unpacked today, using anomaly-based sampling for managing IT changes and for spotting SOD issues and potential fraud and access management, those seem like the most promising places to begin the journey.
I agree. They represent a really compelling combination of high potential benefits and sort of practical feasibility within the current IT audit environment. Good starting points.
This has been a truly fascinating look into where IT audit might be heading. It really makes you think, doesn't it? About how this ever-increasing tide of data is just going to necessitate adopting these kinds of innovative technologies, not just in auditing, but really across all aspects of assurance and risk management.
It really feels like a whole new world of possibilities is unfolding, slowly, perhaps, but surely.
Indeed. And for those of you listening who want to explore this more, we definitely recommend checking out Tom DeVries's thesis if you can, and just generally keeping an eye on this rapidly evolving field of AI in audit.
There's certainly much more to come. It's an exciting space to watch.